Hello, I'm Dushan. I would like to present a project that I've been working on, which started kind of as a proof of concept, which was that some graph representing a shader can be compiled to string and then easily interpreted by three.js via the shader material. So by using the templates of some of these kind of what are referred to as built-in materials, we can extend them. And for now, it kind of works like smart texture or texture editor. Um, I want to recreate one of the examples to show how this works. It could be helpful to someone maybe to visualize kind of the shader flow with what limited resources are there now. It is built with React and three.js, and it's running on the latest version, 163 as of this moment. But one of the ambitious goals of the project is to be able to export this to the older three.js versions as well. So the example I want to make is kind of like a disco floor, a grid of colorful tiles that should change color as time goes by. So I'll start with a basic material, and I will start connecting some nodes. So there are some inputs coming from the geometry. UV is a useful one for this goal. It goes from 0 to 1 in 2 dimensions, hence these colors. Ends up with yellow, where both colors are full. So green and red give yellow. We are going to multiply that. The node I use is a math operator. It's overloaded, so I can change this to multiply. Went to black because the default values are 0. Caps at 1. So I can say maybe 20 is a good number. But now I have to do it in 2 directions. So I will make an input. Since I'm aiming for a square, I will use only one number, a float. We'll call it num_tiles. Same thing, defaults to 1. I would say 10. Go up to 10. And now, if I try to connect this, as soon as I start dragging, some of these will turn to gray. The reason why this one stays on is because I can override it and now to just take over and that part of the graph with a different value. How do I overcome this? There is a node. It's called compose. I can connect this to 2 of the inputs, 2 of the channels, X and Y. And now this one still could go to a wider channel, like maybe a vector 4. But if we go here, now we can control this in 2 directions. So now what could we do next? There are some math operations. Fract will be a good one to visualize what's going on here. Alright, it looks like a grid. We can make some lines. By saying step. And again, same problem. Both directions, they're independent. But as you can see, it's normalized, goes from 0 to 1. One direction, 0 to 1 to the other. We could copy this, call this, say, edge width, and connect it. Now we have 2 inputs. Reduce. Actually, it already is. This is a bug. want this to be a mask, so the green and the red channel should be combined to yield a black and white texture. So we can use min and max, and we can now decompose this vector 2. We end up with two floats. And you get a black and white output. Testing it with edge width, 0 width, no black lines, 1, it's fully a black line. Now, what we could do is color the tiles. For that, I want to use noise. This node takes in a three-dimensional vector, but outputs also a black and white channel. I cannot put in this yet. I want to do a couple of things to it. One would be to floor it. So unlike fract, which gave us kind of this zigzag pattern, floor will push the entire square to have the same value. And because we multiplied it, so now it goes like 0, we can see that rectangle here, or that cell here in the corner, it's black. But as we go up, these are now like 1, 2, 3, 4, 5, and so on. We can use that to now feed it or index into this noise function. Not just yet, because we again need to compose it. It takes a three-dimensional vector. So compose. I can already prepare that. Now I have an output divided by channels, or input, pardon. But it doesn't take a vector 2, so I need to also, unfortunately, decompose it here. So an extra step. And now I have compatible channels. That's one. And that's another. With the C channel, I can kind of animate it, make it wobble like this. Let's see, what could we do next? We can animate it by saying, let's get rid of some of these. There's an input, time. Time goes into the Z. Now it's being animated. We can also keep the number of tiles, but change the scale of the noise function. So for that, use something like this. Copy this. We can call this noise scale. When we floor, you can multiply these two. And now we should get a slightly different noise function. There we go. Now it's like really flickery. Or if I take a really low number, we can actually see kind of the blobs forming up over this grid. Now, in order to make it a color, I want to have some kind of an offset here because if this is just these are three channels aligned one on top of another, so this is we would get a grayscale image if we fed this to all three channels of RGB. If we shift the phase a little bit, we can get a colorful output. So for that, I do believe that we need to clone these 3 times for each of the channels. After that, you need to compose them. So this is red, green, blue, and as I've said, we just got the same output because they aligned. But if we feed that to the shader, we're actually already getting some results. Go switch to cube. We see this on every face. Now, this node, we can shift how they go through time by a little bit. So along the z-axis, I am going to just offset that value by a little bit. I'll move this out of the way, line it up a little bit so it's nicer. This is to show what's happening. I'm going to push them out a little bit. All right, so connect time to both. It's adding 0, so it's the same thing. Replace this. So now green is going through here, blue is going through here. Nothing happened yet, but as I shift these, we get more color. So let's see, this one by 5, this one could go by 1, and hey, it looks like a disco effect. So let's see, the noise is really small. Now it's like a lot more coarse, a lot more dense. There is an issue with the noise function. It also has a negative value, and it may even be going from 0.5 to -5. But for now, let's get rid of there are a lot of black values here because they're going below 0. There's a remap node for that. All three of them will need kind of the same configuration. So in goes the noise. It maps it from, we said, -1 and 1. That's the range it starts in, and we want it to go from 0 to 1. So they're still black. It goes, some of them still go close to 0, but there's a lot more in between what was clamped before. If I copy that over, these configurations persisted. I need to override these connections. And I need to override these ones. There is an issue with color mapping, which stemmed from upgrading this about 50 versions very recently. But this is kind of the end result. This is what the graph looks like. We can add these lines by multiplying the cells. Pass that back in immediately, ready for material. And again, because it's like a single float output, we need to compose it. so it's compatible to this operation. That didn't work because this is an add. And that didn't work because it's a bug. And here's the end result. Okay, so now, if I export this, and I am going to say that I want to generate a TypeScript declaration, and then I want to zip the results. Okay, so I need to find that. I'm going to extract that. I have two files on my computer. So, and I'm going to go to a sandbox that I prepared. This is now all familiar kind of three.js territory. It has .GUI, which is quite common in all of the examples. It's very easy and convenient to control properties of three.js objects with it. And I have a file here where I am going to copy paste. Actually, pardon, no, that would be if I were to copy from the clipboard. I already had this going up here, so let's delete that. I'm going to name it my material. Import it here to source. That didn't work. That kind of broke. Let's see. Get rid of this one. That wasn't as smooth as I was hoping. Let's see. This works. Basic material. So now I'm going to try to import that. I'm going to instantiate it. TypeScript declaration didn't work. Let's see. Yes. Alright, we can deal with that later. It should work, but let's see now. I prepared this sphere here and a mesh. And now if I pass this material to it, it should show up. There's some glitches here with the sandbox, but here it is. Hey, in the application. And as we mentioned, it has an interface that should be user-friendly. So if we go GUI, add, one of them was num tiles. There we go, it's showing 10. And it's working. It's reacting to the interface. Time exists on the material. This is the familiar loop. We can say mat time plus equals delta. And we can see it animating. So other than not getting a type here, this is kind of the end-to-end demo. They're trying to fix the bugs, but if it could be educational or useful to anyone, that would be great. Thanks for hearing me out. If you have had a chance to see this, thank you.